me resume this and cool. So, hey everyone, I'm Chirag. I work for Flipkart Ads team. So today I will be talking about the caching strategies with Apollo client. So before we start, like a very good morning to everyone, because I know this is very early for everyone, even for me it's very early. So okay, before we start, just I wanted to know how many of you have already worked on production with GraphQL. So have used GraphQL on production? No one. No one have yet experimented with GraphQL. Okay, cool. So it's nice enough. I will be starting with the basics of GraphQL. So how GraphQL is different from your REST, and what are the benefits which we get in the GraphQL as compared to the REST, and vice versa both. So uh, GraphQL have a single endpoint where you can make some query, and that information you will get, and that will be decided from your client side. You don't have to define anything on the server, only the schema is defined at the server level. So here the control comes to the client, not at the server. So on the server, you have tightly scripted schema where you say, this is my user information, these are the details of the information that a client can ask. So what all information are different pieces, different feature level that client will be deciding. Say suppose, take an example. This is a slash GraphQL endpoint where I'm querying for the user information where ID is equal to 1. So in that case, if a client says your application level on the client side, you say, I just need a ID. Your server will give just ID. On your network layer, only ID will be written in the response. If you ask, I want name as well, I need address as well. So all these information are asked by client. It's not like REST where you have defined a user API where it will give the information of all about the user. So it is more driven from the client, not from your server side. So how it is better than REST? So only one round trip, you can merge multiple information, user information, your login information, your other setting information in a single query, and you can ask. So there will be a single round trip to the server and from the server, and you will get all the information in a single go. So there is no overfetching and there is no underfetching. So you can ask whatever you want. There is single endpoint, so it provides more flexibility. You don't have to remember what was the endpoint for getting the user information, for settings, for manipulating other stuff. So single endpoint gives you more flexibility. It is more predictable because you can see there is a tight schema which is present on your server. You just need to know this is the schema for this particular query. That's all. You don't need any documentation. You will get by default a GraphQL which is equivalent to your Postman. So what we do on any of the REST client. So REST client help us to say, this is my URL, I want to post this information, I will get this information. So for that you need documentation also, like you need Swagger like documentation where you need to maintain that. Every time you need to publish your Swagger. Over here it's real time. Whenever you make any changes in your schema, by default it will be reflected in your GraphQL. So you have to just share this URL. People can play with this dashboard and they will get this information by default. So this is framework agnostic where you don't have to worry about the language. If you are comfortable with the JavaScript, Java, whatever language you are comfortable with, you can use the GraphQL with along with that. So, but it is also worse than REST. Can anyone tell what is one or the two feature which this GraphQL does not provide as compared to the your REST application? You can. So GraphQL is strictly typed language. So you can say this user informations, this ID is your string, your name is a string, your address is a string, and whatever data type, you can define that. So apart from that, anything? Yeah.
Authorization, because it is using single endpoint.
Okay.
So, in REST, you can have different authorization and different things for particular endpoints. But yes, since you're using only one endpoint.
So for this, actually, having authorization and authentication is GraphQL is far better as compared to REST. So what you can do, you can define, this is my query. Say suppose we are asking for user information. So you can say this user information can only be given to logged in user. So you can define at query level. Second thing, you can say this can be given to only admins and to say suppose other type of users. So this can be done. Apart from that, you can define it at your key level. Say suppose you want to share your settings inside the user only to specific roles. Then you can define if the user permissions are not this, then pass the dummy data or empty data. You won't be sharing that information, and you can define at your response level, or you can say query level, schema level, and individual type level. So it gives you a flexibility to a lot extent. Apart from this, anyone?
Also at field level, is it?
Yeah, field level it is possible. So you can define for this field will be populated only for these users. For others, it will be empty.
Even for querying fields also.
Even for the query, for you any of the schema type, and for the fields, you can define it 3 levels. Apart from this, anything. A very interesting thing which we use in production. Without that, we can't survive. Pagination. I won't go into that. So handling pagination is super easy when you talk about the Apollo client, where you have to write a few lines of code and you will get pagination out of box. That's it.
Caching, you must be talking about, right?
That is one of the things. This is all about my talk. That is a caching. So when we talk about the caching, so how you can cache your API calls. So generally what we use some of the strategies, like we define cache control like max age. We define some of the validator like etags and if modified since kind of stuff. So all of these things we generally define in your REST application, where we know we have settings, we have, say suppose user information, we have other education related information or personal information of the user. So we know there are a few data which generally doesn't get updated very frequently. Then why to get that information on every call or pass the updated information to the client on every call? So that can be easily handled by adding a max age factor or define other policies on the rest. But over here, what we are doing, we are asking for multiple data in a single query. So it's very difficult for a server to define key what should be the max age, what should be the different policies that need to be sent to the user. So there are the different challenges also when we talk about the caching. So this is one of them. What you can do, you can cache the exact queries and the responses in GraphQL as well. Although I won't be drilling down into the policy, you have cache control at your field, query, and your schema level also present when we talk about the Apollo server. But again, that is not that beneficial because the user generally asks multiple information in a single query. So hence, HTTP caching with the GraphQL is mostly useless. So we talked about so many things like GraphQL is this, GraphQL can do lots of stuff. Then if we are not able to cache the stuff, then why GraphQL? So there should be some solution to that. Yeah, so there is a solution. So GraphQL client must re-implement the caching strategy by themselves. So before drilling down how Apollo client does this, so let's drill down to some of the challenges and some of the factors that we need to consider when we talk about the cache. So yeah, there is something. Let's talk about that. So there is something called stillness. We have some data in the cache which is not used anymore. No need for that information. That is just a waste. We have cache. We got the data again from the network, and that data is same as we had in the cache. So then why we made a network call? So there is a sameness factor. Creepiness, sometimes we don't know from where this data is coming. Either that is coming from my cache or that is coming from the network. It's very hard to debug if we talk about the caching. Then we have worthiness. So there are chances when we have lots of data in our cache. In that case, the query time can be more than as compared to the network round trip. So most of the time we have seen when your cache grows, you can better go and make a network call. You will get a response in a faster way as compared to your cache. So we have to take care of those factors as well. So considering example, we'll drill down how the caching works at the Apollo client. So we have two queries. We are asking for the books. In the first, we asked for the book with the title capital. In the second one, we asked about the economics of inequality. In both the queries, their author information is same. So there are two ways to cache this. One is I will cache this entire information based on the query. So there was two query. I will save this information in my cache as it is. So if next time a user asks for the same query, I will give that information as it is. But there are defects with that. There are problems with that. What if anyhow the author information is changed? So it will be reflected in just one, and the other one will have the old data. So is there any better way? Yeah, we have normalized caching. So Apollo client does this normalized caching in a very better way. What it does, it normalizes the data which is coming from your server and store it in itself. So the previous request becomes this. So it takes author and store at a single place and pass the references to the other two places, where one was the book as in title and second one is the economics of inequality. So what is the benefit? If we change this author, so automatically that will be reflected to all the references wherever it is used. Secondly, all your queries which are active queries which are listening to this information on your browser will automatically be updated. So your UI will be automatically refreshed at all the places where this information was populated. Cool. So what we have seen, so we should cache the data based on the data information which is required, not the number of queries which are required in the system. So how can we achieve this in Apollo client? So there is a library called Apollo Cache in memory. What it does, it normalized your result which is coming from the server, it destructure it, and it makes an individual object, attach a unique identifier to it, and flatten this information and store it in itself. So I think how to use this library. This seems to be doing some cool stuff. So just 2 lines. When you are initiating your Apollo client, you need a new instance, new object of in-memory cache, which you get from Apollo cache in memory. That's it. All the data will start flowing through the cache. You're done. So you are ready with your cache. So now how to use this cache with the other benefits altogether. We have different strategies. We have different caching strategies which we can leverage from this cache we have just created. So we'll be talking about direct cache access at the rate client, which helps you to manage your local state as we do in Redux or kind of Mobex and all those things. We will be talking about optimistic UI mutation. We will be talking about persistent cache, and there are network policies which help us to make this caching policies or the cache more efficient to the user. So direct cache. We have this cache with the in-memory cache. So we want to do few stuff. We want to read some information directly from the cache, and we want to update that information in the cache. How to achieve that? If people have used client.query, what it does, it can do 2 things. One, it can read the information from your cache, or it can fetch the information from the remote and update your cache. These are the 2 things which a query does normally, client.query. But we want to make sure we are interacting just with our cache. There is no network call, there is nothing involved in between. So how it can be done? We can use read query, write query, fragments, and write fragments. Do you know what are fragments or some sort of? Yeah, it's a pieces. It's a plain English where you can say this is my schema, and there are some pieces of that can be shared between other schemas as well. So you defined a fragment that can be used at the multiple places. So if you want to explicitly read and write to some of the fragment, so you can do that. So let's see how to read a query. So how many of you are familiar with this code? This is just a GQL query. You are asking for a to-do with the ID 1, and you are asking for ID, text, and completed. This is how we generally make a query. This is the simplest code we have seen. But most of the time we might have seen as in client.query. This is client.read query, which makes sure you are accessing your cache. You are not making any network call, not at all. So this will give you a to-do from your cache with the ID 1, and it will return you information like ID, text, and completed. Second, if you want to modify that. So first of all, we are saying for this ID, we want to update completed with the data where we can see data to do completed is equal to true. So we are updating our completed status of this ID equivalent to 1 in the cache. So we are done. So we have reached some information from the cache, and we are modifying that information on the cache. So we have seen 2 things. Similarly, you can do with the fragment as well. No differences, just a query difference and how we use the fragments. And we can combine this information. We have some to-do list already present in our cache. So what we are doing, we are accessing this from the read query. This query is written on the top. Give me all to-dos, the ID, text, and completed from the cache. Append information which is ID equivalent to 5 with the text hello world and completed and false, and write it back to the cache. So now our cache is updated with a new to-do item, and wherever this query is used in your UI, automatically it will be reflected on the client side. By the way, how many of you know that you can write a resolver on your client as well? So we know we can write our schemas, resolver, and data sources on the server. So is there any way to define your resolvers on the client as well? Cool. No, no issues. By the way, you can. So you can define the similarly resolver which you defined on the remote on the client, similar as in Redux. So in Redux, we have some functions which does some manipulation on the store. So how many of you are aware of Redux? How many of you have used Redux? Okay. So we have something called after action, where it goes. So if we have Redux, we dispatch an action, it goes to reducer. In reducer, what we do, we write some logics in order to modify our state, which is global state. So similarly, over here, you can write your resolver. What it will do, you can get some data from your cache and you can modify your data in the cache so that it is available across your application state. So you can define your resolver. So we'll be talking in the detail what you can do through the resolver, how you can make your own local state through the resolver. So here is an example. Similarly, as we did through the client object, you can do from the cache object. So here the resolver name is, you are doing a mutation with the add to do. What it does, it fetches the information from the cache, it modifies that information and updates back into the cache. So you will get the updated data in the cache and you can utilize it anywhere. So it won't make any network call. So it's just a client side implementation of some logic which is doing your cache updation. Cool. So we have seen we can do some modification just on our cache, but there are real-time implementation where we want to fetch some information from the remote. Based on that information, we want to modify on the client and get the information from the cache. So is there any way to do that? We have something called @client. What it does, we'll see with the example. So you can have your local resolver or local cache. So it will get the information from two places. First, it will check if you have a local resolver. It will go compute it and get the information. Second, it will go to your cache and check if there is the data present in the cache. It will get the information. How to use it? Just a simple, this is your schema where you ask generally, give me to-dos, ID, completed text. You have to just say @client. So it will fetch from your cache and your resolvers only. It won't make any network call. So let's take an example. We are asking for a member where we are asking for the name, role, and is logged in function. So is logged in is defined in your resolver on the client. This is Apollo client. This is a resolver called member. And in that, there's a function called is logged in and it does something. So it may be reading your local storage or some data from the cache and doing some modification. We want to make sure this information is populated or calculated on your client based on some data which we are getting from remote, which is say name and role. What all is happening behind this? First of all, how many of you know what is the default fetch policy for any of the query which we make to the remote? So will it go, it will ask the cache, or it will go to the remote, make the network call, or it will do both the thing? By default, it's cache first. What it does, it will go and check the cache. If the data is present in the cache, it won't make any network call. This is the default policy, how default Apollo client works. So in this case, what will happen? It will go and check your cache. If no data is in cache, it will make a network call. It will take the data from the as a response from the server. It will compute your local resolver, which is logged in this case. It will update your cache, and this updated cache will be available across your application. You're done. So what you have done, you have find some information, you have fetched some information from the remote, modified that information on your local with some resolver, and utilize that information across your application. In this case, it can be logged in user. Say suppose you manually went to your local storage and you have deleted the key. In that case, what do you want? This, so for the second time, it's the data is already in the cache. Your name and role is there. In that case, it won't make any network call. It will directly go into the cache and fetch the information. That's it. But we want to make sure our local resolvers are computed every time. So there are two ways to do that. So what are the two ways? One is Either you change your fetch policy to no cache or network only. In that case, you are saying I will always call a network, always make a network call and get the information from the remote. In that case, your local resolver will always run. Second, you can pass a key which says that allows as in true always. So in that case, your local resolver will be executed every time. So those who have worked with Redux, can someone tell what are the challenges we faced when we have large scale application where multiple teams are working on the Redux store? We have single state, multiple teams are utilizing the same store and facing some problem. What are those problems? Anyone? With any of the, not with the Redux, with any of the local state management library.
Inconsistency.
Consistency.
Have to
Collaborate with other team because they may impact some of the functionality which you are using from that store, right? Or they may modify your code which you have written because the same state is utilized at multiple places.
They might use some of the states and at some different point they might require some modification. They might change that state and it will affect something.
Perfect. Apart from that, there is a major challenge when we have multiple teams. Our state size keep on growing. So irrespective of either I am on info page, catalog page, or whatever page, my entire store is there in my cache. So this is the biggest problem. Right now, I'm an admin. I came for some of the modifications, but why I'm getting the entire store? That is not required. How can someone help us? Do you know what is code splitting? Everyone, I think everyone knows about the code splitting, where I will decide what piece of information that need to be loaded on the client depending on some condition, right? So similarly, if we can achieve our local state as well, I will have all these resolvers depending on some condition and it will be defined by me. So we have, say, suppose 5 modules. So all the resolvers which are used in my module, I will be deciding when to download that and when to utilize that in my Apollo client. This can be done very easily with just 2 lines. You get an object of use Apollo client and you can add your resolver to that wherever required. So you have your checkout team, basically checkout module. So you have written all your resolver logic in that. So whenever you come to that module, you can decide I want to initiate my resolvers related to checkout. You're done. Because that is not required at any other places or in any other module. So you don't have to actually download that. You don't have to manage that. So that can be done very easily. Optimistic mutation. So we won't be talking about how this works, what it is. We'll learn with the example, what it is from the real world example, how we have seen our applications like Facebook and all these applications work. We have Facebook like. Generally, we all use Facebook and we regularly do a like. So what is the experience over there? One way is we click on this like, it will make a network call, it will go to the remote, it will wait until our remote status is updated, and then we will update a counter on the UI +1. Is this a good behavior? What is the problem? User experience is not good. There is a delay, and we don't generally see this delay in the Facebook. Second way, we can add a loader. Until we get some response from the remote, we'll show a small loader to that. Is this a good behavior? We have never seen a loader on the Facebook, never ever. Third, when a user click on this plus icon, what it will do, it will instantly do a update of +1 on local state and it will parallelly make a network call. Once a network call is success, it will update the ID which was generated with respect to that like internally. So if we have to do this manually, there are lots of effort. Before that, let's drill down to the other example. We have a to-do list. One started with a rice entered or clicked on add, it's saying saving. I have to do lot of work. I can't wait for all the network call to be success, then add all the to-do list. Is there any better way? Similarly, with optimistic, you can enter, just add, it will be reflected in your list and you don't have to worry about it. It will be instantly available on your screen. How to achieve this? So let's take the first example where we are adding something, we are waiting for the data to come from the server and we will modify our to-do list. So this is example. So what we are doing, we are making a create to-do call with some new data, which is text. Once this mutation is done, we are updating this information with the existing query, with the existing to-do list which is present in the cache. We are reading that information, modifying with the information which we get for this new to-do list, and writing back into the cache. You're done. So we have saved some information on the remote, got the new ID, new information, updated that in our cache, and similarly it will be reflected in all the places where this to-do list was populated. But how to achieve the second one? So that is very tedious. So if you have to achieve the second experience where you just type a to-do, hit the add button, instantly it is available on your list. So that's it. You have to write an optimistic response, create to-do with some information. You generated a fake ID, use that fake ID, and once your data is saved on the server, this information will be replaced by the original data. That's it. You can get the same behavior of like or any of the real-time application with this. There are some use cases where we want to persist our cache. We are fulfilling some form, we navigated to some other browser or other screen, we accidentally close that screen, but we want, if we visit that website again, that information should persist. But we haven't saved that information to the remote on a server on DB. So how to do that? So one hectic or the not preferred way is, you have to take control of all the queries which you are fetching from the remote, all the updation which you are making to that cache, and you should take care either storing the local storage, session storage, or whatever storage you have on the client. So one way is you manage it. Second way is, I don't care. I will be doing my regular operations. Is there someone who can help me out with this persistent? So with persistence, there are two problems. Two things that we need to consider. One is restore. When we come back to our website, it should restore the data which is present in our store and populate into the cache so that it is available for all the other operations. Second thing, persistent. If we are making some modification, it should persist in our storage so that it is available for the next time. So there are two things. So Apollo gives you Apollo cache persist, where it says, just use me, I will handle everything. How to use that? So when you are initiating your Apollo client, so we generally pass a cache. We modify that cache with a persistent layer with passing a storage in that. So we are saying we will be using window.local storage. There are other options depending on either you are on the web or the mobile, where you are, what you want to use. If you want to use local storage, session storage, all of those are available in the storage. That's it. What it will do, it will help you in the multiple ways. First, this is asynchronous. It won't restrict your operation or it won't delay your operation, what activity you are doing. Second, it helps debounce. It won't impact in the performance. Third, it helps you to define max storage, which is required. We talked about worthiness, where if the data in the cache is very huge and if it is taking a lot of time to fetch any information from the cache, there is no point of having cache. You can directly go to the remote and fetch the information on the real time. So there should be always a max limit to your cache size so that it helps you to define the cache max size. These are the different storage provided. We have for React Native, we have async storage. For web, we have multiple, where we can say local storage, session storage, local storage. And for Ionic, for web and mobile, we have Ionic storage. There are cool thing which is provided out of box with this React Apollo client, which is a very thin layer provided by the Apollo. What it does, it helps you in multiple ways. I will give you two examples. One is, you have a web page where your certain information is used at multiple layers. So consider an example, you have Facebook. In Facebook, you may be populating some of your user information on your header, on your sidebar, on your chat box, on multiple places. Or even where we say, hey, Chirag, let's type some comment or liked by someone. So in that case, all these components are agnostic of each other. They don't know where they are used, whom, when they are used, and why they are used. They are agnostic. They don't know about each other. In that case, if that component tries to fetch the information, user information from the remote, so it will make multiple calls. Each of the component will make an independent call in order to fetch the information. So what thin network layer provided by Apollo client does, it helps in query deduping, where it says if there are same request, same query made at the same time, I will dedupe it. I will make a single query and I will update the cache, and similarly it will be updated in all the places. Very interesting feature. Second, it provides you a policy where you have a control. Either you want the data from the cache or the network, or you want the data from both of the places, but you want a very efficient way to do that. So there are few policies, which is cache first, which is default, where it will ask from your cache. If not present, it will go to the remote and fetch the information and update your cache. So let's drill down how this works. Cache first. You made a query, it will go to the cache. If it is present in the cache, it will give you from the cache. It is not present in the cache, it will make a network call and update your cache. So if you make a subsequent request, it will always get from the cache. Cache and network, very interesting. Where you want information to be instant appear on the web page, but you want to also make sure this information is similar to what we have in the DB. It will do two things. One, it will get the information from the cache instantly. Second, it will make a parallel network call to fetch the information and update your cache. Once your cache is updated with the new data, it will automatically populate the new data on your screen. Third, network only. I want to make sure I have a module like payments or some wallet where I want a real-time data. I don't want any data to be from the cache like money or some sort of. I don't want to show that. I want to make network calls. So network only you can pass. If my applications does not modify the data very frequently, I will be using cache only. So I know I want to make offline chat or offline application where I will be using this policy altogether. This can be configured at two places where you can, first of all, you can modify the default policy, which is cache first at the Apollo client level itself, where I will be saying, I want to use network only policy. So I don't want to specify everywhere. I want to specify at one layer because I know how my application works. Most of the time, I want a real-time data. That's why network only. Second, at a query level itself, I can define generic policy is network only, but I want cache and network or no cache or different policies at the query level. So you can do this. What are the benefits we got out of this? So there is no extra round trips. There is no unnecessary re-rendering on the browser. So it gives a more performance on the browser side. Then if there is any update on the cache, then by default your cached or the query component which are using this cache will be updated. So you don't have to manually go and update. When there is updation in the cache, automatically your query component, your UI will be updated out of box. Better availability. You can have persistent cache. You can define what piece of your application you want to persist in your local store or search engine store, so that is available for your next trip on the web page. Yeah, we are done. So we have learned lots of stuff. We have seen lots of stuff that we can utilize in the cache. So how many of you feel like this? Oh, I've learned lots of stuff, lots of strategies that can be used as an Apollo client caching level. So that's it. Thank you. I'm Chirag. You can find me anywhere, mostly on all the social network, including LinkedIn, Facebook, whatever comes to your mind, Twitter, with just Engineer Chirag as an handle. So that's it. If you have any question, welcome.